Now let's have a closer look at the regression discontinuity design, referring to an article that has been published in a refereed journal. The article is by Lalive, a Swiss economist, published 2008 in the Journal of Econometrics, and this is until today a nice example for an applied RDD approach. It's how to do extended benefits affect unemployment duration. So we want to evaluate the effect of the increase of duration of unemployment benefits, and the increase here is from 30 to 209 weeks for older people, and older means people over 50. So the treatment here is the prolongation of unemployment benefits, so the UB prolongation, and the outcome we primarily look at is the unemployment duration, and theory tells us that the prolongation of unemployment benefits might lead to longer unemployment durations. Well, RDD is applied here. An idea that goes back to the 60s, was forgotten for many years, and a Dutch economist, Wilbert van der Klaaf, came up with one of the first papers with that. Also, Ankrist and Levy, 1999, a paper, Quarterly Journal of Economics, on the Maimonides rule, exploits the discontinuity to estimate the causal effect of class size on scholastic achievements. So I have a separate video on the Maimonides rule because the 1999 paper was followed by a 2019 paper, and we should see that as a whole. So please, I refer here now to a special video, especially on this issue. Well, today RDD is interpreted as a design, therefore we talk about the regression discontinuity design, and the idea is that if there is a discontinuity, if there is a jump in the mean outcome that you observe in the data, then you might have a discontinuity that could be exploited for identifying a causal effect, and then you compare people pretty close to the discontinuity with each other. You're already familiar with these diagrams, so this is from Ankrist-Pischke. Here we have the cutoff point, that's the running variable, and what we observe in the data, just visually analyze that there is a jump, and if there is a jump, then there is a discontinuity that could be exploited, the discontinuity that could be exploited for identifying a causal effect. So the assignment variable that assigns people either to the treatment or to the control group is also called running variable, and sometimes you also see forcing variable, saying that people are forced to either the treatment or the non-treatment. So the treatment is assigned to individuals with a value of X, for example, that's age, right? Greater or equal to the cutoff, and the cutoff is the threshold, is the discontinuity, is the jump. But the jump is not a sufficient precondition, it's kind of first order condition, and you need the second order condition, and more precisely, you're not allowed to be able to manipulate the assignment variable. And if you're not allowed to manipulate the assignment variable, or not able to do that, then there is some variation for people near the threshold if they get the treatment or not. So once again, the assignment variable, let's say that's age. if you were able to manipulate your age, what could be, for example, the case in developing countries where it's not clear when people were born, and then you have the possibility to manipulate your age. And if you're allowed to manipulate your age, then you could manipulate your age in a way that you get access to the program. So assume now the cutoff point would be 50, and you were able to manipulate your age so that you get the program, right? So you get access to the treatment. Then in such a case, RDD wouldn't be allowed to apply, so that wouldn't be plausible to use RDD. However, if you cannot manipulate the assignment variable age, like this is the case in Austria or in Germany, then RDD would be a plausible identification strategy for measuring causal effects. So always two things. The first is that there is a jump, that there is a discontinuity, and the second is that you can plausibly argue that the assignment variable is not manipulated. To a certain extent it's okay, but not to a large scale. This will be also a discussion in the Maimonides rule paper, manipulation of the forcing, running, or assignment variable. Or even more precisely, when individuals have imprecise control over the assignment variable, so cannot manipulate it, even if some are especially likely to have values of x near the cutoff, every individual will have approximately the same probability of having an x that is just above than receiving the treatment, or just below than being denied the treatment, the cutoff. So similar to a coin flip experiment. So you always need some variation or randomness that you get the treatment or you do not get the treatment. So there you need some randomness, variation, that you're either assigned to the program group that gets the treatment or the control group that does not get the treatment. If there is such a randomness due to the design, then you have a plausible identification strategy. So what we do is we differentiate between a called sharp RDD, which is not an IV, instrumental variable. Just very quickly once again, so if you have an endogenous X variable, you are searching for an instrument that is correlated with the endogenous X variable to identify a causal effect on Y. So the IV approach, however, is different to the sharp RDD, because in the IV you must assume that the instrument is exogenously generated as if by a coin flip, which is not that easy to justify, whereas RD mimics a coin flip randomization as a consequence of the assumption that individuals have imprecise control over the assignment variable. So this is something else. However, you find in the Ankrist-Pischke paper textbook the idea that a fuzzy RDD equals an IV. So let's have a closer look to that issue later on. So RDDs are local randomized experiments. So if you're pretty close to the threshold, the cutoff point, then those who are assigned to the treatment group and those who are assigned to the control group should not be very different with respect to the baseline characteristics, and that's what you can check. Are these groups comparable? Well, if it's the age 50, that is the cutoff threshold, well, if you're pretty close to 50, let's say 50 plus 1 day, or 50 and minus, right? minus 1 day. So these are very comparable people. So with respect to baseline characteristics, they should be similar. And then you have a control group and a treatment group that is comparable. Well, this is here now just repetition sharp RD. If the dummy variable equals 1, if xi is above the threshold, which is 50. So if a person is 50 plus, including 50, then gets the treatment, and if not, doesn't get it otherwise, right? And the row here could be interpreted then as a causal effect, and that's just an OLS estimation, controlling for some other observables. So RDD has become more and more popular, also because identification is now better understood, and that's maybe a sentence that might summarize that. If individuals have imprecise control over the assignment variable, then the treatment is as good as randomly assigned around the cutoff. So that's the local randomization around the cutoff. I think that's a pretty good summary of the identification strategy in case of RDD. So once again here you have the X, the forcing variable, assignment variable, or running variable, and you have the outcome variable here on the vertical axis, and once you observe a jump, so that the average of the control and the average outcome of treatment differs to the left and to the right of the cutoff point, then RDD might be plausible in case you cannot manipulate the assignment variable. So this is now from Lemieux. Now let's come to the paper. It's about the Regional Extended Benefit Program, REBP, introduced by the Austrian government in 1988. So it extended the potential duration of UB from 30 weeks to 209 weeks for job seekers who satisfied the following criteria. So let's focus on aged 50 plus. And the program ended in 1993, so this is ex post evaluation. So this program provides a unique opportunity to study the effect of a dramatic increase in the potential benefit duration. The program is strictly targeted with respect to age at entry into unemployment and place of residence. So we have a sharp regression continuity design as long as assignment cannot be manipulated, what is the case here. A relevant institutional design is that there are early retirement schemes that differentiate between men who can get access to that early retirement scheme at age 60 and women can get it 5 years earlier. And due to that fact, REBP is expected to prolong unemployment duration much more strongly for women than for men due to these early retirement rules. So the researcher has good data, rich data, longitudinal data from different sources. Don't want to go through that, but overall good data. The author uses two identification strategies. I will skip the second one, but the first is that the causal effect is identified at the age border between treated and control subjects, and don't want to go through the other border that's more travel time for distances between regions, so let's skip that. Well, and this is the crucial diagram. So you have the running variable x, which is age here on the horizontal axis. Here is the cutoff point, the threshold, the jump, and you have the y variable, the mean outcome here on the vertical axis. And what you see here is that on average, 13 weeks of unemployment duration, and on average, let's say 26 weeks of unemployment duration after the jump. So visually, we can see the discontinuity. And the discontinuity at the threshold is almost 15 weeks. So what about women? Are they really more affected by that policy change? Yes, they are. As you can see here, there is a discontinuity which is much larger. So the discontinuity here at threshold is 109 weeks. Here's the cutoff point once again. So this is an amazing jump. Now let's come to the OLS regression. This is the dummy variable. This is the causal effect alpha 1, and of course some control variables here. Don't want to get into the details of the estimation. Let's focus on the alpha 1, and that's the outcome. So we have a treatment effect of about 15 weeks, which is highly significant, 3 stars. And this is true if you do not control for anything else. So this is here the first identification strategy, and we want to focus on that. And this is the table for men. And if you control for some variables, right, then still the causal effect is there. 14 weeks, also highly significant. And so you can see the RDD identifies a causal effect of unemployment benefit prolongation on unemployment duration. By the way, these are robust standard errors in parentheses clustered on age and distance to the border. So that's what we are familiar with. And yes, if we look at women doing the same analysis, we see after controlling for variables, then we end up with a causal effect of 102 weeks, which is highly significant, much more than the effect on men.